Hi students, this is a Keys to Algebra video. Laura asked a question about book 4, page 28. It's a topic called advanced factoring, and this is a topic that John covers near the end of both the Algebra 1 curriculum and the Algebra 2 curriculum. But my takeaway is that I don't think he puts enough of these problems in the homework because students very often forget how to do this particular kind of factoring. So I'm here to remind you, and P.S. spoilers, it's fun and easy once you get the hang of it. Okay, before I dive into the particulars of this kind of factoring, I'm just going to paint a broader picture. Remember that this is what we call the standard form of a quadratic expression or equation. We can add that on to the end of it or not. It makes a huge difference in the overall problem in many ways, but for our factoring, it doesn't matter if it's an equation or not. These particular problems are not equations, but that wouldn't change anything. And we know that we have an x squared term, an x term, and a plain number term, and we call the numeric coefficients in front of the x's a, b, and c, right? Now we know there are three ways to factor this kind of beast. The first way is the easiest way, and that is by inspection. Right? We find two numbers that multiply to c. They have to meet two conditions, right? First, they have to multiply to c, and they have to add to b, right? And plus or minus signs matter. That's the first way. The second way we can do it is by completing the square. And that is a long, drawn-out process where we kick c to the curb and we find the magic number and we add it to both sides, etc., etc., etc. You know how to do that. John spends quite a bit of time on that. So hopefully you remember those steps. And then remember our third way is the way that mathematicians came up with when they got really tired of completing the square. And they said, let's create a formula that will basically complete the square for us. And we can just plug our numbers A, B, and C into this formula and cut right to the answers without doing all of these steps for completing the square. And we call that by quadratic formula, and that's the man-eating dragon. Okay, those are our three ways to do it. Now, in order for this type to work, the way we learned it, it only works if the coefficient on the x squared term is a 1, or if we can easily divide it away, right? An example of that would be if we had 3x squared plus 3x plus 6, we could divide these all by 3, and we'd end up with x squared plus x plus 2, and then that would satisfy this, right? So this kind of equation is a little caveat. If we can quickly divide away the a, then it still works for this situation. The problem with the problems on page 28 of book 4 is that they have numbers here, but we'd rather not do this. I don't even know if Peter and Julie have touched on these two topics yet in their review, but let's not use these if we can avoid it, right? So is there a way to factor by inspection when a is not equal to 1? And the answer is yes. Let me just write this down and then I'll tell you what I'm saying. okay? If the answers, if the values of x are integers, negative or positive whole numbers, then we're going to be able to use this special factoring by inspection, okay? But if the answers are x equals a fraction, then we need to just go back and rely on these. Okay, this works for anything. Completing the square and using the quadratic formula. If we can get it to work by inspection, either by our original method or by what we're going to call our advanced method of inspection. Okay, so this is like a subset of number one. We want to use this whenever we can. But there will be times when even the advanced method of inspection doesn't work and we just have to rely on these two. Okay, so how does the advanced method of inspection work? That's what my whole point is, right? Advanced factoring. Let me take one of the problems. And remember, this is ax squared plus bx plus c. Notice that these are expressions. There's no equals 0, but that's okay. It wouldn't change how we factor it, so that does not make any difference to our problem. All right, normally what we said is we're looking for two numbers that multiply to c, multiply to c and add to b. That's our regular inspection rule. And I'm writing this down because it's just a twist on this. We want things that multiply to c and add to b. Our advanced inspection rule is that they have to multiply to a times c. So we have to multiply a times c and use that as the number that our two guys have to multiply to. I'll show you in just a second. This is where the change comes in. And then they still add to b. Now, before I go any further, let me say this. For some reason, a lot of math textbooks don't know this little trick. And I must have learned it in college. I don't remember, but John doesn't know this little trick, or at least he doesn't reveal it, and Peter and Julie don't either. But this is the trick. We multiply. So let's reuse the rule and see how it works. First, we do multiply a times c. A times c equals 9 times 1, so that equals 9. So now we're looking for two numbers that multiply to 9 and add to 6. 3 times 3. They multiply to 9 and they add to 6. Okay, now what we do, once we find the numbers, so our steps are 1, find our pair that meet these qualifications. I'll just say that qualify. Then 2, we rewrite as a 4-term expression. Let me show you what I mean by that. Now we know that these are our special numbers, right? Here's our original expression. What I'm going to do, let me just write it over again. 9x squared plus 6x plus 1. We're going to split this term into two pieces using the two numbers that we found. 3x, 3x. These are both positive, right? We don't want negatives there. Then these guys just come down and we tack them onto the front and the end. We don't change these at all, okay? This is the part that's changing. Then we factor in two pairs. And that's easy. We always just do the first two together and the second two together. If these are different numbers, it doesn't matter which way you write them. It'll always turn out. These just happen to be the same. But in one of our other examples, I'll show you it works out either way. Okay, so now we're gonna factor each of these. Oh, this is a squared, I forgot that. Okay, ready? So we look at this, what can we factor out? We can take a 3x out of both of those terms, right? What happens when I pull a 3x from a 9x squared? We're left with 3x. What happens when I pull 3x from 3x? Oh, that's just a 1. Remember, it doesn't go to 0. 3x divided by 3x is not 0, it's 1. Okay, so now I've factored those two. Now I'm over here, and I can see I can't pull anything out of those except a 1. Okay, we can always do that. And then when I pull the 1 out, look what I get. Now, something important happened. What is in the parentheses came out the same for both pairs of factors. That's the way it should always work if you're doing it right. All right, it'll always come out that way. And then what we do is we take the two pieces that are kind of disconnected and we connect them in one set of parentheses, and then so they make that one, and then this is the part that was already in parentheses. So this is our final answer. This one's a little bit confusing. I wish I hadn't done it first because the two binomials are exactly the same. That is kind of weird. Factor in two pairs, and then I always call this last up an art project because all we're doing is just rearranging the pieces, right? We're just making it look nice. Okay, this is our final answer. Let's do another one that has two different factors so that it won't look the same. Okay, 4x squared. This is, again, I'm just pulling examples from your page in Keys to Algebra. 4x squared minus 11x plus 6. Okay, so the first thing we do is we find out what's a times c. That's positive 24, and b is negative 11. All right, so we're looking for two numbers that multiply to a times c, that's 24, and add to minus 11. And I come up with minus 3 and minus 8. Okay, so that's step one. That's finding our pair, right? Now we're gonna rewrite this into 4 terms, splitting this first term into 2 pieces using these numbers. And look and see how this makes sense. This right now is minus 11. I'm gonna turn it into minus 3x minus 8x. Minus 3 minus 11, 8, is minus 11, right? The math on these works. So when I split these, I'm not changing the equation at all. I'm just blowing it out into 2 pieces because then when I combine with this, right? And those don't change at all. Those just copy straight down. Now I've got pairs that are factorable, okay? That's the whole strategy here. And again, this only works if the answers to this, the solutions for x are integers. And we're gonna see one in a minute that doesn't work out that way, all right? But I'm gonna do one more of these. Okay, so let's practice factoring. I can't take any numbers out, but I can pull an x, can't I? So this leaves me with 4x minus 3. And over here, I can pull out, let's see, I can pull out a 2, can't I? But I see, if I pull out a 2, that's gonna leave me with a negative x and a positive 6. I would rather have the minus sign on the negative number. So that tells me instead of pulling out a positive 2, I wanna pull out a negative 2. Because that's gonna make the signs work the way I want them to. When I pull a negative 2 out of this, I'm gonna get positive 4x. Aha, now it matches. And when I pull a negative 2 out of a 6, I'm gonna get a negative 3. Now, I've lined it up. If I got confused, let's say I did the first part, and I didn't catch that trick of pulling the minus sign, and let's just say I pulled a positive 2, I'm looking up here. I'm ignoring this line right now. And I'm pretending that I didn't notice how to fine-tune that minus sign. Let's just say I just said, oh, I'll just pull, I'm sorry, not a 4, but a 2. okay? Then when I pulled the 2 out, I would get a negative 4x, and then I would get a positive 3. And then when I compared these, I would go, my signs are off. The numbers are good, but the signs are off. How can I fix that? And I would say, I need both of these to change. Aha, if I make this a negative, then it fixes, right? So if you make the mistake of, if you don't catch that little trick and you get a second binomial that doesn't match the first one, go back and see if you can figure it out, all right? But I'm gonna squiggle this up because we don't need that. This is where we're at, right? And then my final step is the art project. I gather up those two and I get x minus 2, and it is 4x minus 3. I guess I have to disagree with what I said. This works for numbers that aren't integers, but never mind. Don't worry about that. This is the answer for this one. It works when these numbers are integers, not necessarily the final solution. All right, so this should be the right answer for this one. Let me skip one and take another one that was farther down. And I'm just working off the top of page 28. 16x squared minus 2x minus 5. Again, we calculate a times c, that's going to be negative 40. And we compare it with b, which is minus 2. Oh wait, this is the one I don't want to do yet. Just pause, we'll set this one aside. I'll come back to that one. That's the one that's drama. I wanted to do this one. 6x squared minus 17x plus 5. A times c is 30, b is negative 17. Okay, so I look, what are the two numbers that will multiply to this and add to that? Negative 15 and negative 2, right? They multiply to positive 30 and they add to negative 17. Okay, these numbers are where I need to have integers. That's fine. All right, so now we rewrite this as a 4-part expression, minus 15x minus 2x. This is where I meant to tell you, it doesn't matter what order we write these in. I will show you in this one how it's different. I just write them down in whatever order I think of them. I don't worry about that anything other than just getting these two so that they add properly to that and then multiply to this. That's all that matters. I copy down the first and the last term. They don't change at all. Now I factor the two pairs. I can pull a 3x here and I'll get 2x minus 5. And then here I'm careful again because I can see, oh look, I already have the right numbers, but the signs are backwards. So I'm gonna pull a negative 1 and that will change the sign. That will give me positive 2x minus 5. That's just what I want. Now they match, I'm happy. 3x minus 1, 2x minus 5. An art project to finish it up, right? Beautiful. Okay, what if I would have written these down in the other order? I remember learning this and thinking, I would have gotten it wrong if I wouldn't have done it in this order. How did I know to do it? Spoilers, it works either way. Let's try. Let me do that so we know we're in a new realm. Minus 17x plus 5. Okay, this time we're going to put the minus 2 first. Minus 2x minus 15x plus 5. Okay, so this is splitting. We double check and make sure it's right. Those do indeed add to minus 17, and they multiply to plus 30, which is what our AC value is. Okay, so this is, I did it correctly. I just changed the order, right? So now I'm going to factor with two different pairs. All right, well, let's just carry on. What can I pull out of this? I can take a 2x, and that gives me a 3x minus 1. And then over here, let's see. I can see that I can take a 5. If I take a positive 5, these signs are going to be wrong. So I'm going to take a negative 5, and then that will give me a positive 3x and a negative 1. Okay? Now, I'll gather up my pieces for the art project, 2x minus 5, and then what's in the parentheses already, 3x minus 1. There's my final answer. Look what happens. The difference between this line and this line is that the binomial that's on the inside first up here, the one that we created the first set of binomials, is now on the outside, right? 2x minus 5, 2x minus 5. And the part that was on the outside before, the 3x minus 1, that's now the part that was on the inside, 3x minus 1. So you see, you just gather them in a different order, but you will end up with the very same pair of binomials in the end. And the important thing is that order doesn't matter in multiplication. So that's my way of assuring you that whether you write, it doesn't matter what order you write this pair in, as long as your work is mathematically accurate, it'll work out either way. All right? Okay, so there are 3 examples of problems where we are able to find 2 integers that satisfy this job of multiplying to b and adding to ac. But let's go back to this problem, because maybe I'm spacing out, but I did not have the same good fortune with this one. Let me just make sure I copied it right according to my notes. Maybe I copied it wrong out of the book. I don't think so though, because I checked multiple times. Okay, this is my expression. I find a times c, and that is minus 40, right? 16, I'm just double checking everything. 16 times 5. Oh, there it is, okay. My mistake, 16 times 5 is 80. Okay, beautiful. So what 2 numbers multiply, I caught my mistake, it was multiplication. Now we're fine. The drama is gone. What 2 numbers multiply to negative 80 and add to negative 2? All right, so I can see it's gonna be 10 and 2. One of them will have to be negative. I want the 2 to be negative, I'm sorry, this is an 8. It'll be like this, right? Negative 10 and 8, that multiplies to negative 80, and it adds to negative 2. I'm demonstrating involuntarily how easy it is to make mistakes and just jot down the wrong thing and rush through it. That's one of the big challenges of these keys to algebra, is to stay calm and stay in your zone. And that is a really good practice for taking the AccuPlacer. There's a lot of things flying around, so when you stay calm in the midst of yet another problem, then you're in good shape. Okay, great. So here are my 2 numbers. I'm going to write this. Let's see. Let's just put the minus 10x first and plus 8x. Sometimes students ask me, is there one way to write it that's easier than the other? Like, is there anything that you can do to make this easier at this point? Which I proved to you here, they'll both work out. And what I have to say to you is, it doesn't matter. They're equally easy. So don't worry about it at all. Whichever order the numbers occur to you here, you can just copy it over. It's fine. And then bring down the first and the fourth terms exactly as they are. Okay. I'm ready to factor these. Let's see, I can pull a 2x, and that leaves me with 8x minus 5. Oh, Peter and Julia are really into this. Oh no, this one works out fine. I'm sorry, I thought they were into reversing the signs. This one, it's exactly the way I want it, right? So I'll just factor out a 1. 8x minus 5. And then art project, 2x plus 1, gathering up the pieces, and then 8x minus 5. I don't have the answers to double check these, but since they worked out well, I'm pretty confident that they're right. Okay, so there are 4 examples of these advanced factoring, and I would even call this by inspection. Because factoring by completing the square and by quadratic formula, that's pretty advanced too. But this is an advanced way to factor by inspection. Okay? I hope that answers all your questions. This is, like I said, a topic that comes up again and again, and I don't think John covers it carefully. So thank you for asking, and I hope this helps. Goodbye.